Hi everybody, and what I want to show you now is a video in which we go over algebraic operations with the standard basis vectors. Algebraic operations with the standard basis vectors. So let me just remind you what those standard basis vectors are. If I were to draw out a xy coordinate plane, just very roughly, and I were to go 1 unit along in the x direction, okay, we would call that vector I. That would be vector I. And if we were to go 1 unit along in the y direction, we would call that vector j. Okay, so in theory, if I was to say draw a vector that was represented by I plus j, what I would really be saying is show me a vector that goes 1 unit in the x direction and 1 unit in the y direction. And I could just go over 1 to the right and up 1 in the y, and I could just draw a vector like that. And that vector that you see there, which I'll highlight, that one would be I plus j. Okay, 1 unit in either direction. So the usefulness of having the vectors, the standard basis vectors I and j, is that we can use them kind of in an algebraic way to sometimes simplify or streamline the process of adding components. See, because this vector here, we can call it vector OP. The components of that vector, OP, the components of that vector would be 1, 1, right? That's what the components of those of vector OP would be. Vector OP would have components of 1, comma 1. But like we said, we could equally go ahead and just talk about that vector as being I plus j. All right, so the algebra, as you're going to see in a second, might be quite helpful and quick in terms of our ability to use these. And so let me give you a more complex example that we could possibly encounter where we use algebraic operations. So let's just say, for argument's sake, that we have a vector called vector A. But vector A is fairly complex. It's composed of both an x and a y component, and and specifically what we have is vector A being composed of 2i minus 3j, and then I have vector B, a different vector that is composed of, let's just say, negative 4i plus 2j. Okay, negative 4i plus 2j. And so what if I asked you then, if this is what vector A and B are composed of, what if I said find an expression, or find a vector and then draw it for the expression 2A plus 3B? How would I do that? Well, I would simply use grade 10 math. I would use, and you can even say it's grade 9 math. I would just use the distributive property. So what does that equal? Well, it actually would equal 2, and then remember, A is 2i minus 3j, and then B is 3b, so 3, and then what we've got is negative 4i plus 2j. And then we would go ahead and distribute, and we would say that this is equal to 4i minus 6j minus 12i, and then plus 6j. And then we could combine like terms and say that 4i minus 12i is negative 8i, and then negative 6j plus 6j cancels out. And so all we're left with is negative 8i as our resultant vector. What I like to do afterwards is I like to put my vector symbols in afterwards, because I find it annoying having to constantly stop as I go along the way, and I'll just put lines for now, but I guess you can put little arrows if you want. But you don't want to forget those vector symbols, because if you do forget those vector symbols, you're liable to lose communication, okay? So what we have here is we have vector that is represented by negative 8i. What does that look like? Well, it means that we're going 8 units to the left along the x-axis, negative 8i. That means we are simply going like this. We'll just say like 1, 2, 3, 4, 5, 6, 7, 8, and we're just going to draw a vector that has its tail at the origin and its head at negative 8, 0. And since it is starting at the origin, we would call that a position vector. And that vector represents the resultant of 2a plus 3b. In subsequent videos, what we'll do is we'll introduce three-dimensional vectors, but I just want to give you a quick hint here, because if you look at an XY axis and you observe it, you can also draw in a three-dimensional aspect to it like that. And the z-axis is the three-dimensional axis. Some teachers use this as the z-axis, some use this. We'll discuss this more in the coming days. However, well, my point is the standard basis vector that goes in the z-axis direction is called vector k, and we'll talk about that. But here's the thing. If you see an algebra question that involves the vector k, you can still do the questions without even knowing how to draw three-dimensional vectors, because simply put, you're just using the distributive property. So if you do see problems which I give you in homework that involve a third vector, vector k, please just go ahead and try it, because it's just simple grade 9 and 10 algebra using the distribution process. Okay, so in summary then, remember, we're just using algebraic operations to calculate the result of algebraic expressions involving I and j, and k can simply be added to that as a third variable, and k represents the standard basis vector in the third dimension, also known as the z-axis.